Hey guys, welcome back to the channel. This is a short video testing a marine ECM. This is from Jim Lilly in New Jersey. He sent his computer. His concern is RPMs don't go over 4,000. He had code 41 and code 81. He said he cleared it, but then the code didn't come back. I actually did have the code 41. The computer when the computer came first, actually two times 41. I erased it and I had been running the computer on my simulation fully loaded. 5.0 reference is good. This is for him to see that this is indeed his computer. And I want you to see here, I'm going to put a sunglass onto this. So we had the hours, if I can grab that in here, I might need to use the mouse for that. And I'm going to put the RPMs of what this is running now. So as we can see from the distance now, so we got over 62 minutes and it's running at 5,000, 4,500 RPMs. So no issue. So I'm going to lower the RPMs right now around 600, which is 650 or so. This is usually what I put them in idle. So around there, let me change the map accordingly. I usually use for my testing 12.6, and I'm going to change the TPS again to less than 10% on idle. So around there. So we can see things. I want also, there is only 4 bits that I can select. So let me select the throttle position. Not sure why it's not doing it. Okay, now, and also the manifold pressure. Let me put those on the bottom so you will see the change on different pits based on that. I think that's the most that I can use. Let me just make sure I'm saying that correct. So with RPMs and speed, I want to show that we have start with our malfunction one. I've been running this steadily for that 64 minutes as we see now. What else? Injection milliseconds. They're both the same. Well, I can have more than 4. All right, so injection milliseconds. I'm trying not to cover too much because I have the signals that I want to show on the right side, but I think I can put them in here. All right, so injection milliseconds. This computer has 406 hours of running, history time. And that's it. It's a 5.0. I think it's a Volvo Penta for what I can see on here. This is very common on Volvo Pentas. I got no information of what is this, if it's a GXIE or what it is. Um, but yeah, I have no fault codes. So I'm going to also show right here. I can stop the capture if I want to have right now free running. So I can put a cursor automatically in the B channel, sorry, on the A channel, and that will prevent the signal from walking in the screen so we can see a little better. So green is the EST signal. This is a 50. 5057 has only one EST signal. The yellow is the RPM, and then blue and red are connected to both bank of injectors. This is one driver per 4 injectors per, it's a batch fire injection. So everything looks nice. I like to see these oscillation leftovers in there. Those are fine. Disregard the little glitch that you see in there. This is, again, a simulation. All right, so I'm going to increase again the RPMs. We will see more of the activations and how the signals are shrinking because it's faster, right? So I'm going to go over to close to 4,900 RPMs if possible. All right, so we got 4,700 RPMs. I'm going to change the map to around 18. Yeah, that's fine. And then change the throttle according to like maybe 45 or 46%. And that's going to change different values, not just the injection milliseconds. As you see, it's now 4.2 milliseconds of injection based on the RPMs and all the values that I'm given. Spark Advance or Cam Retard will change. Let me click on here so we can see more in there. Let me see if I can see the Spark Advance. I have not selected. I'm going to have to reselect it. Yeah, it looks like what I have in degrees is only, oh no, yeah, spark advance 40.4. If I reduce the RPMs, let me select that one so we can see that one as well. See what I put in the upper left corner, I mean right corner. Not sure why, but well, we have that now in there. So if I bring the RPMs down, we can see how the spark advance is following the RPM. So I'm not changing anything else. But and you can see the injection millisecond changing as well. So it's based on throttle position and manifold absolute pressure. So those are two main inputs the computer uses in order to change the spark advance and the injection millisecond. So this is a map, not the map sensor, the maps inside the computer, the software, the values the manufacturer has add for this computer to run um, in different RPMs and different throttles and different manifold air pressure. So those are the charts, the values the manufacturer has put into the software to change, spark advance injection based on inputs. So those are all working good. As you can see, I can raise the RPMs, fiber reference is nice and steady, injection millisecond is nice and steady, ESC signal is nice and steady, and I have zero trouble codes. So right now I've been running this computer for almost 70 minutes. So that's over 1 hour. All right, Jim. So I can give you the diagnostic conclusion that nothing is wrong with your computer. I will have to, maybe contact you or you contact me to see exactly if I can help you. But with no codes and nothing to really go by, it's very hard to give you any guidance. The only code that I see it was there, the EST. So I would recommend you to change or to check all the ignition system as far as distributor, ignition module, and coils, and the camshaft or crankshaft position sensor signal. Even though it was not a fault in there, that could also be there. But it's no problems on the firewall reference or anything. So I don't see any problems. I also can see the max engine RPM log was 5,500 RPM. So I am well above 4,000, which is your concern. All right, guys. Again, this is just a test that I always try to, produce and perform for people that are having problems on their boats and cars, and I'm not sure if the problem is there or not. So, but yeah, Jim, your computer is working 100%. I don't see any problems. All right, guys. Thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.